Find each difference. When we have a subtracting negative problem, we can leave and then add the opposite, or leave, change, change. So this is -8 plus +7, which is -1. Find the slope that passes through the points P and Q. Keep in mind we go up or down and then over. So in this case, we're going to go up and then over. With the points here, we have 4 and 12 as our x values. And then we have 8 and 14 as our y values. So to figure out how much we went up, we need to look for the difference between 14 and 8. 14 minus 8 is 6. And then for how far we went over, we went from 4 to 12. So the difference from 12 to 4 is 8. And we divide how far we go up by how far we go over. So this one has a slope of 6/8. Or if we reduce that, that would be a slope of 3/4. So when we're given points without a grid, we're going to take the y values and subtract them. And then we're going to divide by the x values subtracted. We indicate these as this is point 2 and this is point 1. So we're taking the second y value and subtracting the first, 14 minus 8. And then we take the second x value, the 12, and subtract the 4. So you'll see this as y2 minus y1 divided by x2 minus x1. And this isn't an exponent, it's a little subscript telling us which point it came from. Did it come from the first point or the second point? You might also see it written as the change in y divided by the change in x. This little triangle is a delta, a Greek symbol that represents the change. So here it says, consider the line passing through points P and Q and the slope triangle PQR. So that symbol now is representing a triangle. So in geometry aspects, it represents a triangle. In algebra, it represents the change. What are the coordinates of points R? Label them on the graph. So R is lined up in the x direction with this Q coordinate, and it's lined up in the y direction with the P. What is the height of triangle PQR? Label it on the graph. The height is the difference between the y values. So it is y2 minus y1. What is the base? Well, the base is the difference in the x values, which would be x2 minus x1. So what is the slope of the line that passes through points P and Q? It's the height to base ratio. And we also use the letter M to represent slope. You're going to see this pop up more in the future lessons. It says, consider the falling line. Use the slope triangle to find the slope of the line. So it falls from 10 to 4. That falls 6. And then it goes over from 1 to 4, 3. So that's -6 over 3, which comes out to -2. Then it says use the slope formula to find the slope of the line. So this is y2 minus y1. So that is 4 minus 10 divided by x2 minus x1. 4 minus 10 is -6. 4 minus 1 is 3. And that also comes out to -2. For problems 4 through 6, find the slope of the line that passes through the given points. So we'll start with the second and subtract the first point. So we're starting with the y values on top, -1 minus 3, and then the x values go on the bottom, 4 minus 20. -1 minus 3 is -4. 4 minus 20 is -16. A negative divided by a negative gives us a positive, so that could be 4/16. Or we can reduce that. 4 fits into 4 one time, and into 16 4 times. Again, we'll start with the y values. y2 minus y1 divided by the x values minus the first x values. In our warm-up, we saw that this is a leave, change, change problem when we have a minus and negative. So 2 plus +2 is 4, and -7 plus 11 is also 4. 4 divided by 4 gives us a slope of 1. The y values subtracted divided by the x values subtracted. Six minus 16 is -10. 14 minus -21, we can change to addition. 14 plus 21 is 35. 5 goes into both of those. 5 times 2 is 10, and 5 times 7 is 35. For problems 7 and 8, find the slope of the line represented in the table. So we're going to subtract y2 minus y1. Then divide that by x2 minus x1. Four minus 10 is -6. 0 minus -9 is +9. 3 goes into both of these. 3 fits into 6 2 times, and 3 fits into 9 3 times. Again, we'll start with y2 and subtract y1 divided by the subtraction of the x values. Leave, change, change. 2 plus 8 is 10. 2 plus 2 is 4. 2 fits into both of those. 2 times 5 is 10, and 2 times 2 is 4. Even if you use a different set of points from that table, you would still get the same thing when you reduce your fraction. Pay attention to what happens to the slope when it gets closer to being horizontal. So those decimals are getting very small. And as we get closer to being vertical, what's happening to these slopes? So in the vertical slopes, or as we get towards vertical, it grows to a large number. As we move to the horizontal, it gets much, much smaller. Closer and closer to 0. You can see we had 0.03, 0.01. So it's very, very small as we get closer to a horizontal line. And as we become more and more of a vertical line here, it's growing very rapidly. For problems 9 and 10, find the slopes of the line that passes through the given points. So y2 minus y1 divided by x2 minus x1 3 minus 3 is 0. 4 plus 2 is 6. And when we type that in, or we divide 0 into 6 groups, we get 0. So it has a slope of 0. That is a horizontal line. Here we'll start with the y values from y2 and subtract the y values from y1. Then we will divide by the x values. Six plus 2 is 8. 7 minus 7 is 0. When you try to divide by 0 on a calculator, you might get a divide by 0 error. And this is because this slope is considered undefined. It's getting closer and closer to really large numbers, so it's headed off towards infinity. So we use the slope called undefined for vertical lines. Again, you're going to move to page 225 to add more to your graphic organizer here. So we just chatted about a horizontal line has a slope of 0, and a vertical line has a slope that is undefined. We also need to add in our slope formula, which we said is y2 minus y1 divided by x2 minus x1. And then that's the end of lesson 19. Check back for lesson 20 shortly.